Hello, I'm Leonard. I make all the textures for cczerotextures.com, and today I would like to show you how I made this carpet substance in Substance Designer. As you can see, we have a number of different things in there. We have two different colors. We have a different design which you can use, an adjustable design. We also have these little, I call them plushies, or plush things on top of the carpet. I don't know if that's the proper term. And yeah, I would like to show you how I made all of this. As always, this is not like a step-by-step tutorial in the classic sense. I'm not going to rebuild this on camera because this will take forever. Explaining it will take long enough. But yeah, so just like last time, we're going to go through all these different frames so that you can basically get the gist of how I created this. And it all begins up here with the tufts. Now, I'm not actually sure if tuft is like the proper term for this. I just looked up some carpet terminology on the internet and it says that this is called the tuft. I hope that's correct. Anyways, we have these tufts. They all consist of a very simple shape node, which then gets warped a little bit with just a standard Perlin noise. And then it gets beveled and it gets a curve applied to it. Now, the curve exists because by default, the bevel creates very sharp edges around here. And all the curve does is it smoothes out these edges at the top. I repeat this 6 times. I just copied this down and gave the Perlin noise a different seed for every version, like this. And that means that I get 6 different little pieces of fabric, 6 different little strings or tufts. And then I blend all of them with a very simple gradient and a stripes node. This is what the final texture for blending looks like. And this creates two very important effects. On one hand, it obviously adds a gradient, which is going to be hugely important later on when we blend all of these individual tufts together. And what it also does, it adds this very subtle stripes pattern onto the texture, or onto the individual piece. And this is to simulate the effect of a real woven string of wool. So if you look in here, this wool is actually woven from 2 different smaller strings, and I simulate that simply by adding this stripes texture. Now, if you look at it at full scale, it obviously looks ridiculous, but later on, all of this is going to move down into like the pixel level. And in that, it's actually convincing enough to make this look like it was really woven from 2 different strings. So that's great. I now have 6 different outputs with these different little tufts, like this, and they all feed into 4 of these large tile samplers. These are basically the heart of this substance. But before we get to them, we have some more frames to cover, because all these frames also feed into them, so I want to cover them first. We start off with the secondary color pattern. Now, this carpet substance is built like that. There is one color which I call the main color or the primary color. You can adjust this as an A and B version. So in this case, the A version is the light one. So if I make this red, you can see this part of the carpet becomes red. If I take the primary color B and make this green, let's say, you can see this part becomes green. So essentially, we have 4 different colors for the carpet. A and B for the primary, the background, and then A and B for these design patches. And I'm just going to quickly undo that. And what this secondary color pattern does is it decides how these two versions, primary and secondary, are mixed together. So right now I'm using version 1, which is just a very simple tile generator. All of these are really simple nodes, you'll see that. Which is just a really simple tile generator that outputs this pattern, which then goes through a multi-switch. That's so you can choose which design you want for your carpet. So let's try out a few of them. Where is it? Secondary color design type, that's the one. So let's try design number 3, which I think is little circles. Yeah, design 3 is little circles, and you can see the ratio between these this background and the new secondary color has changed. So let's try a few more. Let's try maybe what also looks nice. Maybe a checker node. So that would be input 9. Input 9. Yeah, I think you get the point with this system. So it's really quite powerful. You can create a lot of interesting patterns with it. And it really just runs on a number of different very basic nodes. Some tile generators, a lot of different polygons, some polynoise nodes with added contrast, then some cells, so you can get this camouflage look if you want to. If you make this green and dark green, you can create like a camouflage carpet if you want that. Yeah, the same thing is essentially going on down here. We again have some different patterns. You can see this one has a slightly smaller square pattern, and that's for these little these plushies on top of the carpet. That's the second design element to this carpet. So again, we can go into our main settings for this substance, and we go down to the plush design type. We can again cycle through all these different nodes here. So for example, I can say I want, which one looks nice? Let's say I want these little dots here. So that's input 7. And we get a lot of tiny white dots. Yeah, and both of these elements just run on one grayscale multi-switch. But before all of this moves into the tile samplers, we have this frame, which is I call the secondary color and plush control. It first of all just has another switch, this time not a multi-switch, just a binary switch, and this simply allows the user to completely disable any of these elements. So if you say I don't want these white thingies, then you can just flip the switch and they're completely gone because they get exchanged for this uniform black color, and yeah, then they're gone. Now, what happens next? This part plus this height blending behind the tile samplers is probably the most complicated part of this substance. So first of all, these two designs, this one for the plush and this one for the secondary color, they get blended on top of each other, like so. You can see the secondary color, or the plush, gets subtracted from the secondary color. That's because there doesn't really need to be any kind of tufts or any kind of strands of the carpet behind this plush, because then they would sort of peek through. So we want to completely remove them from the carpet. Then the design also gets inverted, and it moves into the second preparation frame for our tile samplers, which is the noise. As you can see, we have these two different colors in here, which I mentioned, color A and color B. And these are not just noise. This is not just noise, one noise node which blends between this light blue and this dark blue color, because then the individual tufts, they would all have color variations across them, and we don't want that. I just want one light blue tuft all the way through and one dark blue tuft all the way through, as it would exist in real life. And for that, I take a white noise node, add a lot of contrast to it, so it's really just black and white, and then I mix those masks with this noise. So one of them gets the noise, and the other one, if we zoom into the pixel level, gets the inverse noise. And later on, these will feed into two different tile samplers, which later on get blended back together. And this creates the effect that all these tufts have one color, but in the end, we still get this really natural mix of the two colors. The same thing goes on for the secondary color. So again, the design, the mask which decides where the secondary color goes, is just a noisy version of itself inverted. And what you can also see at this point, as I mentioned, the center part where the plush goes, it's not present on either of these masks. So this one is black around here, and then this one is also black, and you can see that means that we get no tufts here in the middle. Now, we're almost there. We quickly need to create this plush base. This is really simple. This is just a clouds texture mixed with a paraboloid shape, just a standard multiplication, and then it gets transformed. Now, why this transformation exists, it's a little bit complicated. It has something to do with the way the tile sampler for the plush down here, and with the way that it places down these individual elements. If you move it to the middle, maybe we can just show that, then this gets slightly out of sync. You can see that. It's no longer properly centered. Again, this is because the individual tufts are primarily up here. The part that you see is primarily the top half of the texture. The bottom part disappears because the tile samplers operate on a max blending mode. And that's why I have to move this part up to the top, so that it receives the same movement or the same placement as the tufts of the carpet. Now we can actually move on to the tile samplers, because this frame is important, but we first of all need to look at the tile samplers. Now, what do these huge nodes actually do? Well, they take in a number of different inputs, in this case 6 pattern inputs on each of them, all coming from the frame over there, and they just place them. They scatter them randomly across the canvas, controlled by a number of different masks. We first of all have the mask input. This comes from our frame all the way down here, where we added in the noise. So this is the noisy mask. And now you can also see why we did this, because if you look right here, we have 2 variations of the same design. This is basically color A, and this will later become color B in the final substance graph. You can see they are not quite similar. They represent the same design, but they're not quite there. And if you blend them together, you will actually get the full carpet for this light blue part. So what other maps do we have? We have a rotation map, because that's another really nice feature of these tile samplers. You can control the way they would rotate the pattern that they are supposed to display. So essentially, if we scroll all the way down to rotation, you can not only just set the rotation like this, you can also apply a random rotation, and you can even control the rotation with a map. And that's great for us, because then I can create this little map over here. It consists of two elements. On the one hand, we just have a parallel noise, just a standard noise, which gets a little bit of contrast added to it, and these small Gaussian spots. Now this is to simulate an effect on real carpets. Let me bring back my reference images. If you zoom into a real carpet, you can see that all these strands, all the tufts, they are not perfectly aligned. They are rotated in a sort of random fashion, but not each individual one is rotated in a random direction, but rather there's like a pattern. For example, if someone walks across the carpet, then he sort of leaves a trail behind, because all these tufts are now facing the same direction. And over time, this creates like a pseudo-random pattern, which I simulate with this noise node. So we have these large-scale deformations, like from moving furniture or just walking across of it, and then a little bit of added randomness to it. Yeah. So this once again goes into all the different tile samplers. Now we have two tile samplers for the primary color, then the same two tile samplers for the secondary color, again with two different designs, with two different variations on them. How do we combine all of these back together to form the final carpet? That's what this height blending node does. It starts off with a pixel processor. This is a custom node with a custom function that I created. And what it does, it simply creates a mask based on which of these two textures, which of these two outputs is the biggest. So if this one is bigger, then the tile sampler gets white, and if this one is bigger, then the tile sampler gets black. And this is achieved using a very simple function. So you can see I sample the two input images, so input 0 and input 1, and if input 1 is bigger, if one of those is bigger, then it outputs either 0 or 1 out here as a float number. Yeah, and this creates this kind of pattern. And now we can actually use this as a mask for our color. So if we go ahead a little bit, we skip some frames over here, you can see that I use this as a factor to blend between the light blue version, which is just light blue, everything is light blue, and the dark blue version. And because this pixel processor creates the mask based on the actual height difference of these two tile samplers, it's actually a pixel perfect noise texture, or a pixel perfect mix between the two colors. And this is the advantage, and this is why I'm doing all of this this height blending, because this looks much more realistic than just using one noise texture to randomly spread the light blue and dark blue color across the canvas. Yeah. Then I once again do the same thing for the secondary color, and then I take these two designs, so the primary color from up here, which I've blended together, and the secondary color, and then again do the same thing like this and blend those together using a max blend function. So we are almost there. You can see we are only missing the tufts, not the tufts, the plush things, which get added right here. And yeah, that's our height map complete. So at this point, all we need to do is the color and the plush color. So for that, I generate a curvature map of that, which just works by creating a normal, then a curvature, and then an auto levels to get the maximum amount of contrast in there. I feed this into a color preparation frame, as I call it. All it does is, we can take a quick look at it. It starts off with this, the raw curvature map, and then it just adds a little bit of noise. So we have a clouds 1 texture, we have the clouds 3, all on a very, very high scale. And in the end, what we end up with is a slightly more noisy version of the original curvature map. That's, oops, I deleted the link there. Okay, this is better. All we end up with is a more noisy version of the original curvature map, and then I can use this. I can feed this into 4 different blend nodes for the 4 individual colors, and this gives me my dark blue for the primary, my light blue, all just by using an add sub node. So I take the plain color and then add sub this gradient on top. The same thing for the secondary color. Now in this case I used 2 very similar blues because I felt like the carpet already had enough detail. So I get this for the secondary color, and then again blending them all back together step by step. So this is the secondary color, this is the primary, I just showed this one, and then these two go back together based on another of those pixel processors. And then we already have all the carpet colors, and then in the end I add in the final plush, which comes from down here, the plush color, which again has one of the pixel processors to find the biggest value, or to find out whether input 0 is bigger or input 1 is bigger. And yeah, this one is really simple. This one doesn't have 2 different colors, color A or B. This one just has one uniform color, which simply gets mixed with a curvature map of these plush, little plush dots. So you can see that's a very simple effect. I just copy those on top of the carpet. And then, as a final detail, I add in some really fine hairs, like this. Those all come from a super simple scratch generator. So I just took a scratch generator with like a lot of distortion, a very high distortion value. Yeah, I'm just blending that on top of the color and the displacement map to have like this extra little bit of detail in there. Yeah, and all of this goes into the outputs frame, so we can take a look at all the outputs again. This is the height blended together from these 4 different, or actually 5 different tile samplers, 4 for the carpet plus 1 for the plush. the normal based on the height map, and we get an ambient occlusion, which is basically just a more contrasted version of the height map. You can see that if we compare the two, ambient occlusion is essentially just the height with a little bit more contrast. The roughness, which for this carpet really isn't as exciting. I really tried to find out like more about the roughness of the carpet, but if you look at any photo online, you can see it's extremely rough. There's really absolutely no reflection in this whatsoever. So for this design, it's really unimportant. It's actually something unusual. Normally, the color, the roughness is something really important to get right, but in this case, it's almost completely white. Yeah, and then we have the base color in the end. And this is the gist of how I made this carpet design. Now again, this was just a very quick overview. You can spend a lot of time looking at these individual nodes and what they do. If you want to take a look at this for yourself, you can do that. All the substance files for this are in the Patreon Google Drive folder. As always, I hope this was like an interesting little insight into how I make these textures. Yeah, and I hope to see you in the next video.